Work with your neighbor, please. Turn. Yeah, sit down for me. Work with your neighbor.
You want us to find the mean of both cities or each city?
It should.
So we can compare it. more minutes. Okay.
This one.
This one. That's it. Sit. Put it there. No, no, no. Cos, contour. Huh? I don't have a white, I have blue. Sure, I have blue. Someone can start on number one. The side of the wall. Somebody want to grab a marker? I'm doing this. Number one. Yes, sir. Yes, sir. Number one, just for Boston. And just explain why I'm doing this.
Just for Boston?
Yeah, just do Boston.
We're limited to A?
Yes, please.
Okay.
It's not the same. Oh, yeah.
Give the copy. I'll do Chicago here, and so we're dealing with here a sample, right? So they picked up 9 people, 9 individual out of Boston, right? Boston has a population, and Chicago has a population, right? So we picked up 9 individuals whose salary is given to us in the thousands. Now the idea here is to be able to determine the mean, median, range, and standard deviation of both cities, and see if there is any variation within the two. And we extend that resource to which is number 1, and we'll answer B, coefficient of variation, right? Coefficient of variation, the idea of having coefficient of variation is to compare 2 different data, right? It can be within the same population, or it can be outside of different population. But coefficient of variation is the only measurement that you can use to compare variation if you have 2 different populations. Okay? So what we're doing here is, or what he's doing is try to find the mean, median, range, as well as the standard deviation of Boston. With that said, I will do mean for Chicago divided by n, where we have 69.4 plus 71.5 plus 65.4 plus 59.9 plus 70.9 plus 68.5 plus 62.9 plus 70.1 plus 60.9. That right here. 60.9 plus divided by 9. Chicago will have 66.6.
Yeah.
Okay. 6, which will be the mean. Right? X bar is the mean. And the median is, what do we know of median? How do we find a median? Middle number, which is true. What's the first thing we have? Go ahead.
You have to put them in order
from least to greatest.
Okay. So you have to go from low to high, or either vice versa, high to low, and then you need to take the middle one. So in this case, we have odd number of datas, right? So it will be 1 number. If it happen to be even, let's say 10, right? It will be 2 of them, then we add and divide it by 2, right? So median equals, what do we get for median?
68.5.
68.5. Okay. Is that everyone what you got?
Wait, is this Boston or Chicago?
We're doing Chicago.
Oh, yeah. 68.
Now range is also another way to measure variation, but range is taking only maximum with minimum, right? So therefore, whatever you have in the middle won't be counted, or at least it doesn't include there. So range is not as much as useful as standard deviation. So range is max value minus minimum value, where the maximum is 71.5 minus 59.9, which will give me 11.6. That's a range. Now, the variance equal S squared, because we're dealing with sample, right? For sample, you have to be very careful that that S squared, which is the variance, equals the sum of all my individual variable minus the mean squared divided by n minus 1. If it was a population, you have sigma squared equals, so I'll put this sample here, equals the sum of all the x's minus mu, right, the mean, we did last week, then capital N, right? So that would be population. So you have to be very careful with the question. So in this case, we're dealing with sample. So we use the sum of all x minus x bar squared over n minus 1. Or you can use the other one, the shortcut. we did or last week or the week before, where you square all the x's and you sum and you square all the datas. So if you do that, that's shorter, but you're already taking care of the mean right here, so you don't have to do it again here. Right? So you take individual values, 60 minus the mean, 68.5. So let me try this 5 rule. 60.9 minus 66.6 squared plus, then I'll take the second one, 69.4 minus 66.6 squared plus, the next one is 71.5 minus 66.6 squared plus 65.4 minus 66.6 squared plus 70.9 minus 66.6 squared. I'll continue here plus 70 right here, so that'll be 68.5 minus 66.6 squared plus 62.9 minus 66.6 plus 70.1 minus 66.6 squared, thank you, squared. And divided by n minus 1, which is n is, what is n? 9, right? N is 9, right?
Yeah.
Divided by 9 minus 1, which is 8. The variance equals 19.84, and the standard deviation equals the square of the variance, which is 19.84 squared. That will give you 4.45. 4.45. Okay. Now, standard deviation. Okay. Huh? All right, great. So, thank you. So what we have now is Boston is that side and Chicago is here, and we're able to determine the standard deviation, the mean, the median for the first polygon. Now, he went to and did for coefficient of variation, which is number B. So I'll do coefficient of variation for Boston and see what really happened with the two different data we have. Can I erase this part?
Yeah.
Now for B, quotient of variation equals the standard deviation divided by the mean times 100. So we have standard deviation of 4.45 divided by the mean of 66.6 times 100%. Then we have 6.7%. So this is the coefficient of variation for Boston, Chicago, and this is Boston, which is 13.1 or 13.04. Now, take a look at the two data. We have coefficient of variation, which is 4%, and we have 13%. What can we conclude from here? Looking at the data. What can we say about Boston? What can we conclude?
It is almost 2 times higher than that in Chicago.
Chicago, okay, that's what you can, the variation was in the two, one is twice as much as the other one was. Looking at the salary, look at the salary from the data. This is the salary of samples taken, right? What can you say about the salary between Chicago and Boston? Looking at the coefficient of variation, knowing that we have this too, what can we conclude? Boston is higher, right? The salary in Boston or the payment out in Boston is higher. And that could be based on living standard, right? It can be expensive living standard in Boston. So therefore the variation within Boston is really differentiate between two highest values, right? If you look at the range, we have 16.6 and we have almost 30, right? So looking at it here between the two, maximum and minimum, we know that Boston has more of the data spread out. Okay? Now, that being said, any question? Any question?
Wait, since the deviation is higher.
I'm sorry?
Since the deviation is higher, what does that mean for Boston? Does it mean like people get paid more?
Well, look, by just looking at the data, right? The highest payment in Boston is 88,000, right? The highest payment in Chicago is 71. Okay, so this tell you is you can say based on living standard in Boston, you pretty much will get paid higher for the same job that you will be able to work in Chicago. Now, we stopped here last week, we finished here, Chebyshev theorem. What I'll do is I'll go over percentile and box plot. Now, we did measure of center, we did measure of variation. Now what we'll do is measure of position, right? So measure of position is tell you in what location you or your score or your data are located within the overall sample you're taking or the overall sample that you have. To be able to do that, we have a few things. This book that emphasizes. The first one is percentile. When we talk about percentile, the first thing that should come to your mind is we're dealing with percent between 0 and 1 to 100 with increment of 1. So every percent with an increment of 1. Okay. Percent 1, percent 2, percent 3. Unlike quartiles, which we'll see why quartiles is different from percentile. But to find a percentile or a position of any score, the first thing you want to be able to do is you need to count the number of values below x. When we talk about x's, in this case, x is your variable, right? X is a variable. So if one of your data here, if you look at the salary, if it can be any of your value, can be x, right? The variable, the individual data here. So any number less than the variable that you're interested in, divided by the total number, that means 9. The total number of samples you have, which is 9, times 100. So by you doing that, what that will tell you that a specific value that you pick, it is what percent below the rest of the data, or what percent above the rest of the data. Okay. So the first thing you wanted to do, you wanted to arrange the data low to high, or high to low. Just like median, you wanted to arrange from the lowest point to the highest point. Okay, that's one requirement for percentile. Once you have that taken care of, you count the number below x, whatever x is that you're interested in, divided by the total number of data, which is the sample you have. In this case, 9 or 10 times 100. That will give you the percentile position of that x that you're looking for. Okay. So one of the requirements is that you arrange it. Now, if it happened to be a fraction, then you want it to round to the nearest whole number. Okay, it's another requirement. This book messes on a lot of things, but the other requirement is that you are able to round to the nearest whole number if it is a fraction. Now, we talk about the percentile. The 50th percentile, right, means p equals 50. So if I'm talking about the 50th percentile, it corresponds to P50. If I'm talking about the first percentile, then I'm talking about the first percentile here. That's how you want it to put it. So percentile goes increment of 1 divided into 99 percentile or 99 points. Why can we go 100? Why is only to P equals 5, the 99 percentile of some data? You're dealing with P equals 99. Why? Why not P100? Okay, good. What else? Think about it. If I have 100 data, 100 individual, the first requirement is number less than, or number of values less than x. Right? If I have 100, or the 100's individual, then anything less than it will be the 99%. Right? Making sense? So 500 individuals, 1 through all the way to 99, and the last person is 100. The requirement is number of values less than x, right? If x has to be this guy, or this guy, if it's the last person 100 is x, then I have to count it from here, less than this individual, which is P99, okay? Divided by 100. That's why it's not all the way to P100. Let me do quartiles and we'll solve problem. Quartiles is a part of, or is a part of percentile. Now instead of dividing into every 1%, we're dividing every quarter, or 25%. Okay. So if I have this line right here, this is P50, or the 50 percentile, right? 50th percentile, which is Q2. Now looking at it, what can we say about this thing? What can we say about Q2, or the quartile 2? Half, which is 50%, which is what was that? The median, right? The median, which is halfway through. You're right, but the median. So the first thing is, if this is the median, you wanted to be able to find the median. Okay, so Q2 is the median. Okay, so there's another quartile, which is Q2, the 25th, P 25th, and I'll have the 25th percent, and Q equals 1. And I have the 75%, P of 75, and then the 75% here, and Q is 3. Right? So increment of 25, right? So this is my minimum, or 0 you can call it, and this is 100, or the maximum point that you have. So we will divide quartiles into 4 individual groups, and instead of percentile where it goes P1, P2, all the way to P99. Right? Now, there's one thing too, to be able to find quartiles, this is the procedure. Let's work out a problem and follow this procedure, instead of saying this is what it is. So let's go back to the one I gave you from the previous class on this chapter. So it goes to number 8 of the one from Tuesday class. Right? So teacher gives 20-point test to 10 individuals, or 10 students. The scores are shown below here. Find the percentile rank of score 12, or the person who scored 12. Right? So we wanted to find out what is his percentile below and above the classroom. Right? What is his location? What's the position that he's standing within that 10 students? So the first thing I wanted to do is, if I was giving 18, 15, I'll copy the problem here, 12, 6, 8, 2, 3, 5, 20, and 10. Right? So we need to find the percentile. To be able to find the percentile, the first thing you wanted to do is arrange the number from the lowest point to the highest. So I start with 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. Okay? Now that's the first thing you wanted to do. I'll read that. Okay. Percentile can go increment of 1%. Okay? So P1, P2, P3. And the idea of percentile is to be able to determine the position of your score in this case. Right? So this individual, so let me just call X1, X2, X3, X4, X5, X6, X7, X8, X9, X10. So we have 10 X's, or 10 variables, or 10 students. We call them 1, 2 through 10. Okay? So our goal is to determine this location for student 7, or X7, okay, that individual variable. So our goal is to determine what percent of the classroom scored below this person, which is individual X7, or above them. Okay? So the first thing you wanted to do is percentile. is number of values below x divided by total number you have times 100%. So how many numbers are below that individual 7 or x7?
6.
6, right? So you wanted to count how many students below this person, the value that you're interested in. Okay, so there are 6 individuals here. So what I wanted to do is 6. What is my total number? 10 students, right? So I have 10 students times that 100%. So the percentile for this individual or student 7, okay, would be 60th percentile. So what this means is that this individual performed 60. The class score here shown here, he performed better than 60% of the classroom. Okay, so he did better than 60% of the classroom individuals or the students. Yeah. Okay, student 7 performed better than 60% of the classroom. So that's his position. Okay. Now I don't want to add too much to it, but some books add 0.5 to this equation. Okay. Now this our book doesn't mention it, I won't get to it. But the idea of that is when it comes to the last data, that will make a difference. Okay. So I won't get to it, but just know that percentile is number of values below the variables that you're interested in divided by the total data you have times 100. So student number 7 scored 60% better than the classroom. Okay. 1. Any question, percentile wise?
How do you get the total number of values?
The total number of values, the total number of data you have. The total number of, in this case, the total number of students.
How do you know where to cut it off?
I'm sorry?
You know how you cut off the data at 12?
No, the question says right here. The question is telling you that the score are shown below, find the percentile rank for the student who scored 12.
Oh.
Okay? So this has 10 students, that is their score. So student number 1 scored 2 out of 20, student number 2 scored 3 out of 20, right? All the way down. So what we try to determine is this student, whoever that student is, who scored 12 out of 20, and wanted to find out his position in the classroom, his performance in the classroom. Okay? So the total number is the total number of data. Okay? Now, let's go to quartiles. Quartiles, as I said, is a part of percentile, right? They're a part of percentile, but instead of going increment of 1, it goes with increment of 25%. So the idea here is to find every 25th person. So to do that, the first thing we wanted to do is arrange the data, which is already arranged, so I'll just copy that. Oh, they're not the same, so I'll copy the whole thing, 15, 13, 6, 5, 12, 15, 22, and 18. So we do number 9. So this is data given to us, and want to find out the quartiles. So the first thing I wanted to do is arrange the data, right? So the first thing you wanted to do is go from high to low or low to high with this data. So to do that, I have 5, 6, 12, 13, 14, 18, 20, I'm sorry, 15.
No, 14 or 15.
We don't
Or
have
14
14.
and
We know
16.
14 now.
We don't have 14.
Okay.
We have 15,
15, 18,
22.
22, 50, okay. So the first thing is easier to find is Q2. Q2 is the median, right? If you try to find what Q1 is, then you'll spend the whole time. The first thing you want to tackle is Q2, because Q2 is the 50 percentile, and it's the median. All right. So Q2 equals the median. So the way to find the median is what we did was we take one from left and we take another one from right side. So if I take 5 out, I'll take 50. If I take 22, I'll take 6. I'll take 18. Then I'm left with two data, right? So I left with 13 plus 15 divided by 2, that is 14. I was giving you the answer in the first place. But 14, right? So 14 is the median. Okay, the 50 percentile point is now is 14. So far clear? Now, the next thing says find Q1. To find the Q1 is the median of the lowest point below the median, the actual Q2. So anything below this guy will take those data out. So to find Q1, I'll take everything below the median point. So that would be 5, 6, 12, and 13. That's what it says. Find Q1 is the median of the lower half of the data, not including Q2. Q2 is 14, so we don't include it. So we'll take anything below 14 or Q2. Okay? So we take anything below 14 or Q2 to find Q1. So we take this out, we'll do the same thing. We'll find the median of this. Okay? To find the median, I'll take 1, I'll take 1. I left with this 2, so Q1 equals 6 plus 12 divided by 2, that is 9, right? Now, Q1 is 9, somewhere right here. Somewhere right here. Okay? That's Q1, the 25th percentile. Q3 is the same thing, but you don't include Q2 or the median, so you take anything above it. So we go back to number 4, find Q3. Q3 is the median of the upper half, not including Q2 or the median. So we'll take anything that is Q3, anything above it, that will be 15, 18, 22, 50. Okay? Now we'll do the same thing. We take the median of that. Bridget, question? Clear? Okay. So we'll take half of this. So if I take one from left and right, I'm left with Q3 equals 18 plus 22 divided by 2, that is 20. Okay? Now what we have is Q1 equals 9, Q2 equals 14, Q3 equals 20. Okay? That is quartiles. Okay? Percentile quartiles, clear? Any question? How much? Go ahead. No? Okay. Now the last thing is to find interquartile range. Interquartile range is the difference between Q3 and Q1. Okay. Interquartile range, or IQR, is the difference between Q3 and Q1. Now, who cares about IQR with the interquartile range? Well, the purpose of having IQR is that it will tell you the data within right here, where the middle is, how the data is spread, or if the data is spreading too wide or too small. Okay. So the idea of interquartile range, or IQR, by subtracting Q3 from Q1, will tell you how the data is spread in the middle. So the idea of interquartile range of IQR is you're subtracting Q3 from Q1, and that will tell you how the data is spread in the middle. Okay. Is that clear? Why IQR? So to do that, IQR equals Q3 minus Q1. I'm sorry? That is Q3 is 20 minus
9.
9. IQR equals 11. So percentiles and IQR, quartiles are the same thing. One goes increment of 1 percentile, P1 through P99, with division of 1. Quartiles goes every 25th percentile. Okay? So you only have four divisions, as you can see here, between the minimum in the Q1, Q1 to Q2, which is median, which is P50, right? And the third one is Q3 and the maximum point about Q3. A lot of times this is used in business. They divided the year into quarters, and they do their receipts and incomes and expense, all that stuff. So a lot of times this part of the concept used in business. Now, the government also put out every quarter's data regarding employment, how the country doing, GDP, divided into a year. So some quartiles they perform better, some don't perform better. So it'll tell you data spread, how the data spread within that each quartiles. Now, we have to take one more step to using this information, percentile and quartiles, to graph box plot. So for everything that we have done in chapter 2, there is graph to represent data, right? And this is one of them, the box and whisker plot. To do that, you need Q1, Q2, Q3, and then the minimum and the maximum. So take a look at this little graph I have here. You have the minimum, Q1, the median, Q3, and the maximum. So you have 5 numbers, right? Right? So that is called the 5-number summary. Five-number summary. So when we graph box and whisker plot, the first thing you wanted to do is whatever increment that you have, okay, whatever increment that you have, you wanted to graph it, just like dot plot, right? So the first thing I wanted to do is, well, my minimum data is 5, the maximum is 50. So if I go increment of, let's say, what do I have? 0, 10, I have 5. So if I start at 5 here, the next one is 10, 15, 20, 25, 30, 35, 40, 45, and 50. Great. So what I'm doing, I have all this information, Q1, Q2, Q3 from that problem. And I know the minimum, and I know the maximum, right? The minimum is 5, the maximum is 50. So I know those two, so I'll include those here. Minimum equals 5, and the maximum point you can have is 50. Alright? So this is called a 5-number summary, and this is used to graph box and whisker plot. So the first data you have is 5. So the minimum point you have is 5. The way I do it is there's multiple ways to do it, and I usually just bubble it where the number corresponds to. So Q1 is 9, so 9 is right here roughly, right? And the next one is 14. 14 is roughly here, which is your Q2. And the last one is Q3 is 20. 20 is right here. And the last data with the maximum you have is 50 right here. So my box will be within Q1 and Q3. That's the only place your box will be. So the idea of box, right? So this is called box, and this is the whisker. Okay? That little thing is called a whisker. And this is the box. So the box is including Q1, Q2, Q3. and the whisker, which is the true line, will be the minimum and the maximum. So if I go from here to draw my box somewhere here, and I'll come here down, right here like that, and then halfway through, all the way down here, all the way down here, that is a minimum. This is your maximum, and this is your Q3, and then your median, Q2, and this is also Q1. By looking at it, this graph will tell you a lot of things. The first thing is how the data is spread, right? I have 50 here. This is an outlier, right? You can tell this is really outlier. It's far away from the rest of the data, sitting extremely far away. Looking at it here, you can tell if your distribution is normal, symmetric, bell shape, what kind of distribution you have. In this case, I have a normal distribution. See, quality spread out, at least close enough. So this will tell you how your data looks. And this summarizes the 5-number summary, which is the max, minimum, Q1, Q2, Q3. Go ahead.
How do you know that's normal distribution?
By looking at it, it's equally distributed. Look at this graph. Where the median was in Q1 and Q2, and Q2 and Q3, you have normal distributed. And also your whiskers, or those little minimum and maximum, they are equally distributed. Given this, as I said, if this is not my extremely large or outlier, this is a normal, look like a normal distribution. Otherwise it's skewed. But this distribution is normal, equally spread out both sides from the Q2. Okay, symmetry from Q2. So we'll tell you if your data is extremely far away, if it's an outlier, or if you have a normal distribution that looks like just like this. This is a normal distribution. Equal distributed from the mean, right? So the idea of equal distribution, if I have histogram here, where if that's my data, right? This is the median, right? We talked about it. Median and mode are equal here. So therefore, they're equally distributed both sides. Look at this distribution. If that's my mean, my Q2, the median, they're equally distributed both sides, right? So symmetry. So that's the idea of normal distribution. By looking at it, I will tell you how the distribution is. Okay? Does that make sense? Any question for chapter 3? Oof.
So I have a question about the IQR. What exactly does that number mean?
IQR is this, the difference between the quartile 3 and quartile 1, where it tell you the spread of the data in the middle. Because if you subtract Q3 and Q1, right, that tell you the range was in, let's go back to that graphic. Right. If all of them are within increments of 25, IQR is the difference of the two, of the data in the middle spread, of that data in the middle spread. Doesn't tell you anything about Q2, but how that data is spread here. Okay. All right. So, chapter 4, probability. We'll get started. Start 20 minutes or 15 minutes. So in this chapter, we'll talk about a few things. Probability event on section 4.1, which is what is probability, and explain law of large number. Right? It's a rule or it's a law. It's called law of large number. Apply the basic probability rules. And I added a few things because it broke me a bunch of stuff. So we'll get to it. I'll explain. Probability is a part of branch of mathematics, and it's a part of statistics. And if it wasn't for probability, then statistics does not exist. I would say that much. So probability is it deals with the likelihood of any event happening. Right? Likelihood of any event happening. We talk about probability. Usually, is expressed in number between 0 and 1. So usually we're dealing with between 0 and 1. What's the probability of getting hit by a car? What's the probability of winning the Mega Million? What's the probability of your insurance price will go up? Right? All this stuff deals with between 0 and 1. So likelihood of something happening. Now, I have a penny, right? If I toss a penny, right, it can be either head or tail. I don't know what it is, because it's a ground. Assuming the floor is flat and it falls perfect. But what we know is they both have equal chance, right? 50-50, right? Equal chance. So probability determines the outcome of something, the outcome of some event. Right? If I toss a dice, right, I have 6 faces or 6 sides. All of them have equal chance, assuming the floor is flat, right? So if I toss here, I'll get 2 to become the event, and that is a probability of 1/6. Right? So each side have equal chance. So probability deals with the likelihood of any event happening, and usually range between 0 and 1. Okay? Now, a probability close to 1 is that you know for sure that event will occur. Okay? So the more you get close to 1, between the range of so if I have 1 to 1, the more I approach 1, I'm sure that event will occur. Okay? The more I get close to 0, okay, that probability won't happen. A range between 0 and 1. Okay. Now look at it here. If this means the probability of some event A. It can be anything. When we talk about that event A, in this case can be anything. Okay? Probability of anything. So we'll call it A, event A, equals 1, then you're sure that event didn't happen. The probability of event A, or any event, equals 0, that it did not occur. Go ahead.
I think you made a mistake.
Yes, I have.
Yeah.
Change it to 0, not 1. That cannot happen. I think on the new print is 1, 0. The one I gave you today.
Oh,
But yeah, so if some event, the probability of some event equals to 0, close to 0, you're sure that event won't happen. Now, take a look at this. Winning a lottery, right? Impossible. When we say impossible, it's not that it won't happen, but the probability of that you winning a Mega Million is so small that you should not play. Get a coffee was $2, so $3 that you'll spend. Right? And we'll do one problem that deals with Mega Million. If I throw a coin, I have equal chance either getting a tail or either getting a head, right? 50-50 or 0.5, 0.5. Right? Now, I'm not sure if we can have a snow, but based on past experience that I'm certain that we'll have a snow this winter, right? So it's possible. I'm not saying it will happen or won't happen, but it's possible from past experience and this the weather we have, right? It's getting cold, we assume it's possible. But impossible to win a lottery, given the probability. Right? We can determine the probability of having snow this winter using all of the data that existed. How many years did it snow, and it will be 1 over the total of the years that it snowed. And you have more accurate value as compared to winning a lottery. If I throw a dice, I have equal chance, or if I throw a coin, I have equal chance getting either a tail or a head. Now, this is just a few things that says we'll do Mega Million, which have the same probability, right? So you one chance winning that mega, in this case, Powerball, will be 1 in 176 million being able to win that. So it's very, very small. But we know that you will get either head or tail when you toss a coin. Now there are 3 types of probability. The first one is theoretical probability. That's the only thing that the book talks about. There is relative frequency probability and subjective probability, which is the next slide. Theoretical probability is based on equal likely outcomes of any event. Okay, this is the most useful and most used theory in a sense that every event that you have equal chance or equal likelihood of for that event to occur. Okay, so the formula is the probability of event E or any event, in this case I just talk about the probability of you getting tail or head, equals the number of outcomes in your event, in that case tossing a coin, divided by the total outcomes you have in your sample space, which we'll talk about what sample space is. So if I throw dice, right? If I throw dice, I got 5. So you'll have, picking up that 5, you have 1/6 probability picking that 5. Our interest is one number, so which is 1 over the total, which is in your sample space, there's 6. 6 possibilities, so, or 6 different faces that you can have this dice landing on the floor, right? 6 possible faces. Frequency or relative frequency probability is something you already observe, data that you have. Here, you're projecting. You're saying things will happen. Here you have data. Based on that, you know the frequency or how often that thing will occur, divided by the total data we have. So this goes back to chapter 2 when we did frequency distribution. To find the mean median for frequency distribution, we use the same formula, right? Frequency of the class divided by the total frequency. The same thing here. That will tell you the probability of something happening. So if I ask you 25 students here question regarding how the weather is today, and if I give you between yes, no, and maybe questions, right? Some student will answer yes, some will say no, some will say maybe, right? So I have those data in a frequency way. So 5 people can say yes, 10 people will say no, and the rest of which is 10 student will say maybe. Right? So those are the frequency distribution we talked about in chapter 2. But using that, we can determine the relative probability of a frequency data. Subjective probability is you're employing here past data you have. Good example will be weather, right? Based on past data they have, how the weather will be, they will project in a few days we'll have rain, in a few days we'll have snow, or temperature will be cold or hot. Right? They don't know what exactly tomorrow will be, but they have data that can project tomorrow will be close to this temperature. Right? Or if you look into ESPN or a football outcome, right, based on past experience of the team played, they usually say, oh, this team will perform when it comes to this playing with another team. They'll say they won't perform as much as with other team because of the experience they have. That doesn't mean they will lose or win, but based on the previous experience with that individual team, they can project saying, okay, this match will be the same as the previous ones. Okay? So they're just employing here experience they had in the past. That doesn't mean that is true, right? The team can win playing again with the same team. But again, they're just employing that experience they had. Okay, that's called subject. So we'll stick to a lot of this one, which is theoretical probability where events have equal chance or the likelihood of being picked are equal. The law of large number by itself is a huge topic, but what I wanted to say is, if I toss a coin, first, let's say I'm performing 10 experiments. 10 experiments. Okay. So I'll just toss 10 times. If I toss 10 times, right, the first one can be either head or tail, the next one will be either head or tail. I can have all of my 10 experiment tail, right? Or I can have all of my 10 experiment tail, or I can have a mix of both, different variation. Given that, that doesn't tell me much about what the paying will do. Right? I know that either head or tail have 1/2 or 50% chance. Right? So the idea of law of large number, especially when it comes to probability, it says that if you perform or if you increase your sample size or sample experiment that you have here to very, very large number, you should get the theoretical value of that probability. So the theoretical value of me getting either head or tail is 50%, right? Right? If I toss one coin, that will be 50%, either head or tail. Okay? Equally chance. So law of large number, if you increase your experiment, very, very, very huge number, large number, that when you perform that experiment, you should approach to your theoretical value, which is 1/2. That's the law of large number. And you should do this experiment in your house, tossing a coin 1,000 times, and you will see should approach to 1/2 or 0.5. Okay. But if I have 10 experiments, all of them can be tail, all of them can be head, or I can have a mix of both, right? But if I increase this to 100, 1,000, 10,000, then I should approach close to 1/2 the end of the day. Okay. So that's the idea of law of large number. And it goes to talking about the mean, all that stuff. But for probability, just know that if you increase your sample experiment to very, very large samples, then you should approach the theoretical value of that event. If I toss a dice and I'm interested only getting 2, but I should approach to 1/6. Now, every experiment that I throw, I don't get 2. I can get 4, which is still have 1/6, but I'm only interested in getting 2. So at the end of the day, if I sum all of my experiments, that's very large data, I should approach, when I look into 2, I should approach to 1/6. Okay? That is the law of large number. And usually it's used in insurance and casinos. I don't know if you guys travel to Connecticut, Folkswood. Every day they change the shoes, especially blackjack. Every day they put a brand new card, a brand new shoe, and the purpose of it is because that card has been played the whole day. We'll approach to that theoretical value, especially blackjack, where you almost 40% of your data is higher number or higher than 10, 10, 9, all the Qs and A's. So that's 40% of your data. So the more you play, you are approaching to the theoretical value of winning that strike. So every morning they replace a brand new card, brand new shoes, and part of it is to benefit. If I play that card all day, I'll change the thickness, and change all that stuff. They're very too sensitive. If you travel there, you see a lot of cool stuff that deals with, especially this chapter, probability and part of chapter 5. I'm all set. We'll continue Tuesday on this part. Everyone sign it? I already extended.
What does it do?
It's extended to the 5, I think.
The 5th of October?
Yes, sir.
That's it.
Any question, I will stay here. If you have a question,
Now what?
if you have a question, I will stay here.
Yeah, I should have it.
Wait for my next class.
Is it,
I'll check right now. Are you in a rush?
is it
Hey,
an hour?
are you in a rush right now?
Oh, no.
Let me just check that. Go ahead.
Is it an hour? I have at 6, Wednesdays,
6 to 8:45.
yeah, Wednesdays.
What class is it though?
All right, so you should have it.
Oh.
Let me check your name.
What
Check your
teacher do
name
you have?
if you see it there.
Miss Heather.
I think, yeah, I see my email.
You see it there? So
Yeah.
you should have this file.
What English one is
I have the book for it.
Yeah.
I think we got a different
Have
email.
the little manual
sorry?
too
I
and
don't think I got this email, I just got a different one, it just says like homework online.
This is it.
Nice.
This is says.
which one are you using, the
The
other
check
one, the bigger
PowerPoint.
version of the little one?
I don't know.
Is that really, or is it?
Oh, I can resend it right
It's
now.
like,
Okay.
I'm sorry.
but I
Oh,
can't
just
write on
send
it
it right
because I read
The
it.
email that I got it just said,
Oh, yeah, she's
I
making us
posted the
like
homework online.
fill this in, but there's like
Yeah,
a
that's
lot of
enough.
like essays.
That's way, way back.
But do you have
that was
the
also
bigger
the
version
wrong
of the
one.
manual?
Just forward to yourself.
Right.
I have your email, you forward it.
Yeah.
Yeah, that's-
They give the percentage and then they
It
ask
wasn't
for
that hard.
the,
I would just disengage.
and then they
The
ask
first one
you
was
for
just like a
the.
personal narrative.
Personal-
Did you do that?
Yeah.
Yeah. And then we did like
They
the last
ask
one
for
was like
the
an argument
video.
essay.
How I'm gonna get it
I'm
because.
doing an argument essay again. I
Well,
should
take
get
what?
it actually, but I don't
Easier,
want to get.
easiest question. You just think about
But 111 was easy.
But you have to
Yeah,
start by,
Yeah.
Alright, thank you.
not by 1 to 8, 5 or,
You think
No.
but that's really confusing.
it. No, this is the question.
Alright.
It's not hard.
No, it's not, I just hate writing.
Undo after the journal,
There's no reason.
after
Yeah.
you paste and
Yeah, that
scroll
one, I have to use that
to
one too.
Oh,
percentile for that. What percentage
Just
weight
want
is
you
all
to
that's
use
scored?
it just in case you need help, like.
That's
By
good,
things.
but you have to think about the maximum one or
No.
What are you gonna ask?
Sure, this is 85% and anything below.
below is 80, 84, 82, 83.
I just don't understand the
Well,
coefficient of variation.
Think about it.
Yeah, because I didn't know how yesterday, how word I couldn't get it, I don't know.
Standard
Well,
deviation
85.
divided by-
Yeah.
So
Is
this?
what is below.
So
85% of the students are below.
let's say Boston, right? Ignore Chicago.
85% of the
Is
students are
this
below.
divided by that?
She scored 85.
That's not,
Yeah.
that's the median.
Think about there's
Oh,
100
so
students, she's
it's
85.
divided by.
How many are there below?
this.
85 below.
Just standard
85 of them
deviation.
below.
This
Oh, okay.
divided,
By this.
Before, 85.
Oh, that's it?
Minus-
that's it.
But I don't get the
Minus
percentage.
100, that's, oh.
And times 100.
I read the book to see, I can
No, just
get it
easy.
before you said, oh my lord.
Yeah, that gives you the
But I have another question because I don't, English is not my English.
But you usually have to have like 2 or 3
2, 3, what?
datas.
Yeah, I would. So, yeah,
See, you
I'll
have
start
2
with-
datas here,
Mhm.
data sets.
Yeah.
So if you only have 1 there and the other one is with
When they say
Oh,
the
okay.
total cost
Because
of
it's
them
to-
I just want you to
was
compare it.
for
Yeah.
the
Yeah,
same.
okay.
Simple random.
It's a simple one? When you
It's
say
a-
simple
it's a-
one,
it's a simple
yeah.
random, it's-
Because just make me confused.
No,
that's
we
the
talk about
best.
simple random,
Yeah,
simply.
when this is simple one, that's always think about it.
Yeah.
Okay.
Let's say you toss it. The probability is 1/2 because it has 2 sides. If you test it 3 times, doesn't it go to,
How important is
doesn't it, the
But for that
probability?
case, 1 hour is not gonna be enough for other thing. Yeah, I don't know how he's gonna do it.
What was we-
Yeah.
1/8,
Bye.
it's to the power, that's what I'm gonna ask you.
Yes.
It's whatever you have to the power of how many times you're doing
Yes,
it.
you can think of that.
Okay.
Professor, do you think 1 hour gonna be enough to do the exam?
There's plenty of time.
Plenty time, come on.
I'll
Depends
stay-
how
I'll
you
stay-
do,
I'll stay
I will
here.
give it to us.
I'll stay a few minutes. I'll stay here until whatever.
Because I have to look, to already set up for my son, because by 5:30 I have to pick up him to go to football with him. That's why, if we're gonna say I have to find someone to pick up him to go.
We'll find him.
Yeah, that
And
will be
then
great,
we-
because 1 hour is not gonna be enough.
It's an hour 15 minutes, an hour 20 minutes.
That's a lot of time.
I don't know, Tom, for that we got other stuff, depend the exam,
Sure,
yeah. Depend what you give it to us.
that is true.
Okay,
Have a good day.
you too, thank you so much.
You're welcome.
I took statistics in high school and I think it was interquartile range. We used 1.5 in some of those equations. I don't know why.
Okay, that is,
Is that different?
yes, so the 1.5 you multiply with IQR is to find the outliers.
Oh yeah. You.
To find that, you remember that 50 is far
Yeah,
away
yeah,
there?
yeah.
So if we calculated all that equation, we should determine that 50 is out.
Yeah, I remember you calculate everything and you know if it's normal or
Within
there
the
are
range,
outliers.
yes, so the, when you multiply the 1.5 to the IQR, will give the minimum and maximum.
Yeah.
Within that range is your normal data, anything outside it is outlier. Unfortunately, this book doesn't have it. The previous book we had, or the workshop we did, is not as that. But yeah, so you would multiply to find outliers.
And I don't know why, but for population and sample, we learned first we had S for standard deviation and the mean X bar. And then it wasn't for population or sample, it was just there. She didn't say anything,
So
my
just
teacher.
specify.
Yeah, and first we had the X bar and S for standard deviation, and then when we got into the standard deviation a little bit deeper, she said, now that you know, you don't have to use S, you have to use that little circle.
Circle,
Yeah. and she never said there's a difference between those. And I was like, really? That makes so much more sense.
Statistics deals with sample population. You can't do population research because you'll waste time.
Yeah.
So the best bet is to get it right. So I try to push that spread before we get to, because everything we'll talk about will be population and sample. And this is for sample, this is for population. So if I don't specify that, we'll maybe clarify it, then we'll have to.
Are we gonna have a project?
Yes, I was gonna at least mention, but it will be a project.
Is it gonna be like real world?
Yes, so
We're gonna have
the
to
past,
go out and
sure, the past, I have the option of people picking up their own project if they wanted to, anything you wanted to, or researching, or I'll give you an option where you pick. So the summer one, since it's a very short period of time, summer class, the one we did was the number of texts you see, the number of texts you made up was in week range, was in summer time, and determine the probability of getting the text from some guy between the hours of 2 to 5, let's say, of the day. Based on that week, then I can multiply the team. So that kind of stuff, that's one of the things. Another group did, they went out and looked for MBTA data, so I have some information on MBTA and since most of the coffee stores does not exist in MBTA stations, so I figured using data that existed from other train stations that happen to have a coffee store, and using that to determine if it's feasible to have a coffee store. The community college, right, doesn't have one. It's maybe you want to try things like that. There's a few things with it, but I want to do something with Subway, the sandwich Subway. But we'll see. So this is still playing around with it. We'll be group because 25 students in the classroom.
Yeah.
So looking forward, yeah. Usually try to just look into it quite quick. Yeah, a group of 4 by 24 is about 6 group, about 6 students, so some have 6 students, but that will work out, okay. So I'll usually give out once I get through this chapter. So at least you have chapter 3 and chapter 4 you can work with it. As we progress, I add more to it. So it doesn't pile up for 1 week. Drive nuts. So start early. But a lot of people wait until last minute. You start early, tackle the chapter 3 one, questions, tackle 4, by then you finish 5.
I started thinking about statistics in every of my classes. So what happened was, the other day I was in English class, and the teacher told us to write down about ourselves 2 true things and 1 false thing. And as I was listening to the class, almost like everybody, except like 2 or 3 people, had the second one false. And that was really interesting, because I had the second one false too. Because like first you write something true and then you get creative with something.
And then you go to the truths.
Yeah.
Yeah. That's fine. I enjoy it. It's a lot of time. I try to think of that sense. Well, the data I hear doesn't exist. 68% of the people doesn't know the president or the owners. You try to ask the people.
Yeah.
You know, it's just questionable. You can't. There's nothing much to it. Does not address everybody's question. But it gave you something. And when it comes to real application of science and engineering aspect, it's really applicable. It's just life. That's it. Making sense now, the lecture from.
Well, everything, I understood everything because I already took and I did a lot of calculus and
Yeah.
statistics by myself over the summer. But I would understand why people wouldn't understand before, because I don't know, I knew everything, so I understood everything, but some people around me were talking about how they didn't get it, and it's pretty easy to think of.
It is,
Very
it is absolutely the easiest course, but it's the hardest to comprehend in the sense that you try to relate to life. Okay, if I see the problem to give him a coin, and in the past I used a set of card decks, and people say, lost. You say, how many do we have? How many king do we have? Literally, so that will throw you off, and almost everything that has to do with that is using that in examples. People just have no idea. So, I don't know, I'll try to make it, stable from the casting aspect of it. We'll use one or two examples, but not much, rather than just application.
And the little works before
Yeah.
the lectures, that's really helps.
Yeah, I think so. I think people,
Group work,
it does make a big difference.
yeah.
People like it. And I like it, so you can see people make mistakes.
Try
So,
to-
yeah, so we'll continue that. If it takes 15, 20 minutes, it's better to tackle it now. Reduce
Oops. Sorry. I just have another class.
Oh, here?
Yeah, sucks.
Oh, wow.
Yeah,
Really?
not happy about it.
The same set?
I
Same
was
thing.
in the same thing.
That's boring.
I have to be here until 8:45.
Oh,
That's bad.
what class?
English 112. Yeah, class writing too.
It's a lot easier than me.
Actually, this is a little harder.
This one? Yeah, I know. So English would be a lot easier than this
Yeah,
class.
all I have to do is write. But I hate writing.
Everybody hates writing.
Here you do.
So what time is the class?
At 6.
I have the same thing but Wednesdays.
Okay. So I have to come here.
It sucks.
Well, depending on your teacher.
No, I just don't like being here late. It was the only class left, so I had to take it.
You stack to
Yeah.
Do you live nearby?
Mhm.
Okay, then what do you complain about then?
Well, not. I have to take a bus to go home still, but just one bus.
Okay, so it's
That's okay.
miserable.
Yeah, I got that.
I have to take a train and then walk half an hour to my house.
Half an hour.
Where do you live?
Huh?
Where do you live? And you come to Malden High? Oh, you didn't mind though, right? That's far.
I was kind of, I don't work, I don't do anything,
Oh,
just schoolwork, just.
oh. You don't mind, yeah.
He's getting his exercise, daily exercise, so
Yeah.
what else can you want?
Next semester's gonna be 5 classes.
Really? Like hard ones though?